Good morning, students. Already we have discussed about the introduction and laboratory preparations of ethine. Now we will know about the physical and chemical properties of ethine. The physical properties of ethine are: acetylene is a colorless gas. This ethine or acetylene is a colorless gas, and the odor of pure ethine is ether smell, like a sweetening smell. But if it is having the impurities like phosphine or hydrogen sulfide, it will be getting of garlic smell. Understand the physical properties? The first is the color and smell. And the ethine smell, if it is pure, it will be ether smell. And if it is having the impurities like phosphine or hydrogen sulfide, it will be getting the garlic smell. And this is negligibly soluble in water. That means very little percent it will be soluble in water. But in organic solvents like alcohol or acetone, it will be highly soluble. This ethine will be soluble in organic solvents and very less soluble in water. And it is lighter than air. This ethine gas is very lighter than air, and its melting point, it will melt this hydrogen gas, ethane gas will be melts at a temperature of minus 84 degrees Celsius, and its boiling point will be, that means it will changes into gas at the temperature of minus 75 degrees Celsius. These are the physical properties of ethine, and the uses of ethine are: it is used in the oxyacetylene flame. Oxyacetylene flame, that means which will be used for the welding of the metals, cutting and welding of the metals it is used, and it is used as an illuminant in oxyacetylene lamps. Understand, it is used in the oxyacetylene lamps, and it is also used for the artificial ripening and preservation of the fruits. In order to ripen the fruits quickly, we will send this gas, that is ethane gas or ethene gas also we can send it. Understand? And even in the preservation of the fruits. And it is also used in the manufacturing of polymers, rubbers, plastic, acetic acid, oxalic acid. These ethine will be used in all these for the manufacture. These are the physical properties and uses of ethine. Now let us know the chemical properties of ethine. So in the chemical properties, it will take the oxidation reaction as well as the addition reaction. Understand? What is oxidation or combustion? That means burning of the substances in presence of the oxygen or adding of oxygen is called as oxidation. So here for the ethine, if it is burned in presence of the oxygen, it will give rise to carbon dioxide, water vapor, and a large amount of heat. This delta symbol represents it is a heat. Heat will be given out. This is the oxidation or combustion reaction of ethine. Next is the addition reactions. As if these alkynes are unsaturated hydrocarbons, they will undergo the addition reactions. So in the addition reaction, addition of hydrogen will be taken place, or catalytic hydrogenation. That means addition of hydrogen will be taken place. As if it is a triple bond, saturated, unsaturated hydrocarbon, so that this it will be taken an addition of hydrogen in presence of the nickel or platinum or palladium will be taken place and forms as ethine will be formed or changes to ethene. Ethene again will be taken reaction with hydrogen, again addition of hydrogen will be taken place and forms as ethane. Understand? Ethine, ethene, ethane. So this is the reaction with hydrogen, addition of hydrogen. Next is addition with the halogens. The reaction, halogens means fluorine, chlorine, bromine, iodine, but may not be taken place reaction with the fluorine, but they may be taken reaction with chlorine, bromine and iodine. And as if the reaction is similar with bromine and iodine, I have written only the reaction with chlorine. So this ethyne will take reaction, and that too in presence of the inert solvent of a carbon tetrachloride. In presence of the carbon tetrachloride, this reaction will take place. Whenever it is taken place in presence of inert solvent like carbon tetrachloride, it is not any explosive. So ethyne with chlorine will take reaction in presence of the inert solvent of carbon tetrachloride and gives rise to 1,2-dichloroethene. Understand? Ethyne triple bond will be changed into the double bond. And again, here also one more reaction. This is the first step reaction. This is the second step reaction. Ethene triple bond will be changed into double bond, and double bond will be changed in the second step. Double bond will be changed into the single bond. So here also triple bond will be changed into double bond, and again a reaction with the chlorine. Some more chlorine will be gives rise to the single bond. So finally it will be giving rise to 1,1,2,2 tetrachloroethane. As if it is taking reaction with chlorine, that's why we are calling it as tetrachloroethane. If the reaction is taking place with the iodine, we can write it as 1,1,2,2 tetrabromoethane. Understand? So depending upon the halogen we have taken, we have to write this formula. So if it is taken place in presence of the inert solvent CCl4, we are getting this reaction. But if it is taken reaction, if the chlorine is taken reaction directly with acetylene in presence of the sunlight, it will become explosive and it will be forming as ethyne will take reaction with chlorine and gives rise to carbon and 2HCl. Understand? This is the reaction. And then we are having two more reactions also. That is addition of a HCl. Addition of HCl will be taken place. Let us see that two more reactions. Addition of HCl and addition of ozone. Addition of HCl. That means if we are adding HCl, here also the same type of reactions will be taken place. First, the triple bond will be changed into the double bond. First, the triple bond will be changed into the double bond, so that it will be changed. It will changes like this. Okay. So here the addition will be taken place. So one of the hydrogen will be getting towards this side and the chlorine will be getting towards this side of the triple bond. So that it has become CH2 double bond CHCl. And again in the second step, for this we will again add this HCl. Again on adding HCl, it will become as CH3 CHCl2. Okay, CH3 CHCl2 will be taking place, and this is called as chloroethane. Understand? This is chloroethane. Okay, and this one, what do we call this one? Chloroethene. Why? Because double bond is there, so that we call it as chloroethene. So from ethyne, this will be changed to chloroethene, and this chloroethene again in presence of the HCl, it will be giving rise to chloroethane. And again, not only with this, it will also take reaction with ozone. What is the ozone formula? Ozone formula is O3. So CH triple bond CH plus O3, and it will give rise to this it will be formed. And now it is satisfying the tetravalency of carbon, and it is also taking place the addition reaction, and this is called as acetylene ozonide. Acetylene ozonide. Understand? So with ozone, this acetylene will take reaction with ozone and forms as acetylene ozonide. And as if this is an addition reaction, the breaking of the triple bond will be taking place and forms all the single bond. These are the physical and chemical properties and uses of alkynes. Thank you, children.